Here's a practice problem, which involves looking at a number of different relationships and terminology that involve sets. So, question 1, list the elements in each set. So let's start with the universal set, which for this example is the natural numbers from 1 to 20 inclusive. So we're going to list each element in that set. So 1, 2, 3, 4, 5, and so forth, all the way up to the number 20. Now, wasn't explicitly asked in this question, but we can also determine n of u, the number of elements in the universal set, and for this one's probably pretty trivial. There'd be 20. Let's go on to the next one, set E. So E is the set of even numbers. So we have 2, 4, 6, 8, 10. 12, 14, 16, 18, and 20. Now, it doesn't explicitly say we only want the even numbers up to 20, but since the universal set is the set of all natural numbers from 1 to 20, we don't go any further than 20. We're only interested in the even numbers which are in the universal set. So the number of elements in set E is 10. Next, T. T was the set of numbers divisible by 10. So we have the number 10 and we have the number 20. Again, we're only interested in the numbers that are in our universal set U. And the number of elements in set T in this case is 2. Last one is n, the set of numbers divisible by 19. So n would only contain 19. Number of elements in set n is 1. Okay, so that is our sets. Question number 2 says list any disjoint sets. So for question 2, which sets are disjoint? 2 sets are disjoint if they do not have any elements in common. So we know right away that nothing here is going to be disjoint with the universal set. The universal set has some elements, so any of these sets, the elements that they contain, would have to be present in the universal set, unless they were perhaps empty, but none of them are empty. So if we compare E to T, those are not disjoint because they both contain at least one element in common, 10. Now, they also contain the element 20, but they only need to contain one element in common for them to be disjoint. E and N, however, N has 19, and 19 is not present in E. E has all of these elements, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, but none of them are in the set N. So E and N are disjoint. They do not have any elements in common. Similarly, T and N. T has 10 and 20. N has 19. None of those 2 sets have any elements in common with each other, so those would also be disjoint. So T and N are disjoint sets. Question number 3 asked us, list all subset relationships. There are many subset relationships in this case. Now, something is a subset if all of the elements in one set are contained in the other. Let's just start with N. N has the element 19. 19 is not in T. 19 is not in E. 19 is in U, however. So N is a subset of U. But N is also a subset of one other set. There's another set here that contains the element 19, and it is N. N is a subset of N because everything in set N is also in set N. I know this perhaps looks a little awkward, But by the definition, sets can be subsets of themselves. Okay, let's look at T. T was the numbers that were divisible by 10. So 10 and 20. 10 and 20 are both in E. 10 and 20 are also both in U. So that means that T is a subset of both of those. So T is a subset of E. T is a subset of U. And of course, T is also a subset of T. It's a subset of itself. E was the set of even numbers, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. We can see that each one of those numbers is present in the universal set. It has to be present in the universal set for it to be present in E. So E is a subset of the universal set. And E is, of course, a subset of itself. And finally, U is a subset of U. So these would be all of our subset relationships. Okay, last problem. We were asked to draw a Venn diagram to represent the relationship between each of these sets. So a Venn diagram, we're going to represent the sets themselves with shapes. I'm going to start by drawing this box. Apologize for my poor box drawing skills, but this box is going to represent U, the universal set. The universal set has 20 elements in it, so everything that's in the universal set is going to be inside of this box. Now let's look at N. N was 19. 19 is a part of the universal set, so it's going to be contained inside this large rectangle. Next was T. T contained 10 and 20. Those are both within the universal set. Please note that T and N don't have any elements in common, so these are drawn separate from each other inside of U. E, however, did have elements in common. So when we look at set E, it contained 10 and 20, and it also contained some other elements, 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. So when we draw E, we're going to draw it like so, such that E contains these elements, and it also contains the elements in T. From this, we can very clearly see that T is a subset of E. Everything that is in set T is also in set E. And then there are other elements which are in the universal set, but they are not in E, T, or N. So 1, 3, 5, 7, 9, 11, 13, 15, 17. Not 19, because 19 is in the set N. You may note that this diagram is not to scale. And that's okay. When we're dealing with Venn diagrams, they do not have to be drawn to scale. What is important is that we accurately record the relationship between all of these sets and all of these elements. That is what a Venn diagram is for. It shows us the relationship between sets, which sets overlap, which sets are subsets, so that we can just tell by observation what some of these relationships are. So I hope that this example helped give you an overview of some of the terminology involved in set notation and showed you how some of these terms relate to each other when it comes to sets.